You can call an LLM with a 15-line Python script and an API key. It works. It takes 5 minutes, and it costs you nothing to set up. So the only interesting question about Bedrock is, what does it give you that the 15-line script does not? And if you cannot answer that, you should not be using it. You should use the script. Let me be blunt about the wrong reasons first, because they are the common ones. Bedrock is not faster. It is not cheaper. Model pricing is broadly comparable and sometimes worse. And it does not give you a better model. It gives you access to the same models from Anthropic, Meta, Mistral, Amazon, and others behind one API. So what is it actually for? 3 things, and they are unglamorous, and they are the reason large companies use it. The data boundary, the EM integration, and the network path. Your prompts and your data stay inside your AWS account. Access is controlled by the same IAM policies as everything else you own, and the traffic can go over a VPC endpoint and never touch the public internet. If you work at a bank, those 3 sentences are the entire business case, and nothing else on this list matters. If you are building a side project, they buy you nothing, and you should use the script. 9 concepts, and I will be honest about the parts of Bedrock I think you should be careful with, because some of it is genuinely good and some of it is a managed version of a thing you should probably own. Let us make the value proposition precise, because it is easy to get wrong in an interview. When you call a model provider's API directly, your prompt, which may contain your customer's data, your source code, your internal documents, leaves your infrastructure and travels to a third party. For most people, that is completely fine, and the providers have reasonable policies. But for a regulated industry, it is a compliance event. Your legal team wants to know where the data went, who could see it, under what contract, in which jurisdiction, and whether it might be used for training. With Bedrock, the model runs inside AWS, under your account's boundary. AWS does not use your prompts to train the models. It sits under your existing AWS agreements, your existing BAA if you have one, and your existing audit story, and that last point is the one that actually closes the deal, because it means the security review is a small conversation rather than a 6-month procurement. You do not manage a separate API key that somebody will eventually commit to a repository. Access to a model is an IAM permission on a role, auditable in CloudTrail, revocable centrally, and every single call is logged with who made it. Anyone who has tried to answer the question which team is spending $40,000 a month on this API key will understand immediately why that matters. And the network. With a VPC endpoint, your model calls never traverse the public internet at all. So, the honest framing, and this is the sentence to use, Bedrock is not an AI product. It is a compliance and governance product that happens to serve models. If those 3 things are worth nothing to you, Bedrock is worth nothing to you, and that is a perfectly good conclusion to reach. Concept 1. The things that will trip you up on day 1. 4 things that will cost you an afternoon if nobody tells you. 1. Models are not enabled by default. You must explicitly request access to each model family in the console, and until you do, the API returns an access denied that reads like an IAM problem. So you go and debug your IAM policy, which is fine, and the real cause is a checkbox somewhere else entirely. Some models also require you to accept an end-user license agreement, and for some you must submit a use case. 2. Model availability is regional, and it is uneven. The newest model may exist in Virginia and not in the region where your data is legally required to live. And for a European bank, that is not an inconvenience. It is a hard stop, and it is the kind of thing you must check before you design an architecture around a specific model. 3. Inference profiles, which are relatively new and confuse people. A cross-region inference profile lets Bedrock route your request to whichever region has capacity, which improves throughput and reduces throttling. But read that carefully, because it means your request may be served in a different region than the one you called. If you are using Bedrock precisely because of data residency, then a cross-region profile can quietly undermine the entire reason you chose it. Know whether yours is enabled. And 4. Quotas. Default token per minute and request per minute limits are lower than people expect, and you will hit them in load testing, not in development, so raise them early, because the request goes through a queue and it is not instant. Concept 2. 2 APIs, and you should use the second one. Bedrock gives you two ways in, and choosing wrong will cost you a rewrite. Invoke model is the original. You send a raw request body, and that body's shape is different for every model family. Anthropic wants one JSON structure, Meta wants another. Amazon's own models want a third, which means the moment you want to switch model, which is the entire point of a multi-model platform, you are rewriting your request and response handling. You have taken a service whose main selling point is choice and coupled yourself to one option. The Converse API fixes this. It is a unified interface. One message format, one way to pass a system prompt, one way to configure temperature and max tokens, one shape for tool use, one for streaming. You swap the model ID and everything else stays the same. Use Converse. There is essentially no good reason to write new code against invoke model, and if you have existing code on it, migrating is usually worth the afternoon it takes. And a few things worth knowing about the surface. Streaming is Converse stream, and you want it for anything a human is waiting on, because time to first token is what people actually perceive as speed. Tool use, function calling, is supported through Converse in a model-agnostic way, and that is the foundation for agents. Guide rails attach at the API call, and a genuine cost lever people miss, prompt caching, which lets you mark a large, stable prefix, a long system prompt, a big document, so it is not reprocessed on every turn. If you have a long system prompt and a chatty conversation, that is a large saving for nearly no work, and almost nobody switches it on. Concept 3. Managed RAG and the honest limits. A Bedrock knowledge base is managed RAG. Pointed at documents in S3, choose a vector store, open search serverless, Aurora with PG vector, Pinecone, and it handles the ingestion pipeline, chunking, embedding, indexing, and syncing when your documents change. Then retrieve and generate does retrieval and generation in one call, and gives you citations back, which is genuinely useful and which people underestimate. What is good about it? You get a working RAG pipeline in an afternoon rather than a fortnight. The sync is handled and the citations are there without you building them. For a document queue and a tool over a corpus of PDFs, this is a completely reasonable choice and I would not argue with you. Now the ceiling, and this is where I have to be honest, and it connects directly to the RAG episode where the whole thesis was that RAG is not an AI problem, it is a search problem. Retrieval quality is the product, and a managed pipeline gives you limited control over exactly the levers that determine retrieval quality. Your chunking strategy is largely chosen for you. Customer rankers are constrained. Hybrid search, combining key, word, and vector, which is usually what actually fixes bad retrieval, is limited compared to rolling your own, and metadata filtering is more rigid than you will want. So, when your knowledge base returns the wrong chunks, and it will, your ability to fix that is bounded by what the service exposes. The rule I would give you: start with a knowledge base, because getting to a working baseline fast is worth a great deal, and most projects die before they ever need more. But know that if retrieval quality becomes your bottleneck, and in a serious product it will, you will outgrow it, and you should not be surprised by that, and you should not architect as though it will never happen. Concept 4. The safety layer, and what it cannot do. Guardrails is a policy layer that sits on both sides of the model. It filters content by category: hate, violence, sexual content, insults, with configurable thresholds. It blocks topics you define in natural language, so you can say do not discuss competitor products. It detects and redacts PII, which is the feature I would actually turn on for most enterprise use because it stops a customer's credit card number ending up in a prompt log. It applies word filters, and it does contextual grounding checks, which is a genuine attempt at catching hallucination by verifying that the response is actually supported by the retrieved source. Crucially, it applies to both the input and the output, and it is model independent, so it works the same across every model you use, and it is auditable, which matters when a regulator asks what controls you had. That is all genuinely useful. Now the limits, and I want you to hold both of these at once. Guardrails are a classifier, and classifiers have false positives and false negatives, so you will block a legitimate medical question because it mentioned a drug, and you will occasionally miss something you wanted caught, and both of those will happen to you. They add latency, because there is an extra inference step on the path. They cost money per request. And most importantly, and this is the sentence that matters, they do not solve prompt injection. Go back to the NCP episode. If your model has tools and an attacker can get text into its context, then guardrails filtering the output does not stop the model from having already called a tool and done something harmful. Guardrails are a content filter, not an authorization boundary, and confusing the two is how people build systems that feel safe and are not necessary, not sufficient. Concept 5. Agents and the maths you cannot escape. Bedrock agents give you a managed agent loop. You define action groups, which are Lambda functions with an open API schema describing what they do, attach a knowledge base, and Bedrock orchestrates the reasoning loop, deciding when to call which tool, and it handles session state for you. It is a real convenience, and the Lambda integration means your tools are just functions you already know how to write and deploy. But everything from the AI agents episode still applies, and no amount of AWS managing the loop changes any of it. The reliability maths is unchanged. If each step is 95% reliable, then 20 steps is 0.95 to the 20th, which is 36%. That is multiplication, and AWS cannot manage it away. Debugging is still hard, arguably harder, because the orchestration is now inside a service rather than in your code. So when the agent takes a stupid path, you have traces to read rather than a loop to step through. Cost still compounds, because every step is a model call and a long agent trajectory is an expensive one. And prompt injection is now genuinely dangerous because the model has tools that do things in your account. So the honest advice, and it is the same advice as always, prefer a workflow to an agent whenever the steps are knowable. If you know the sequence, write the sequence. A step functions state machine that calls a model at 3 specific points is more reliable, more debuggable, and cheaper than an agent that decides what to do each time. Reach for an agent only when the path genuinely cannot be known in advance, and then constrain it hard. Few tools, least privilege on every one of them, a step limit, and human confirmation before anything destructive or irreversible. Managed does not mean reliable, it just means somebody else runs the loop that is failing. Concept 6. Where the money goes. On demand, you pay per 1,000 input tokens and per 1,000 output tokens, with no commitment. Output tokens cost several times more than input tokens, which is worth internalizing because it changes what you optimize. A long response is far more expensive than a long prompt, so please summarize this in 50 words as a genuine cost control, not just a style preference. Provision throughput. You buy dedicated model capacity by the hour with a commitment of 1 or 6 months. It is a lot of money, and it only makes sense at genuinely high, sustained volume, or when you need guaranteed throughput with no throttling, or if you have customized a model. And it is the only way to serve a fine-tuned model, which surprises people who tried fine-tuning and then discovered the hosting bill. Now the levers, in the order I would apply them. First, use a smaller model. This is by far the biggest lever, and it is the one people skip because it feels like giving up. Most production tasks, classification, extraction, routing, summarizing, do not need the frontier model. And a small model is often 10 times cheaper and 3 times faster with no measurable quality loss on your task. But notice you cannot know that without an eval set, which is exactly the point I made in the prompt engineering episode. Without measurement, you cannot safely downgrade, so you stay on the expensive model out of fear. Second, prompt caching for stable prefixes. Third, batch inference, which is significantly cheaper for anything not user-facing. Fourth, cap max tokens, since output is the expensive side. And watch it. Bedrock emits cloud watch metrics for tokens, and you should alarm on spend before the invoice teaches you. The bill for an LLM feature is a function of how much text you generate, and generating less is free. Concept 7. The decision stated plainly. Use Bedrock when you are in a regulated industry and the data boundary is a hard requirement. This is the case, and it is sufficient on its own. When you are already deep in AWS and want IAM, CloudTrail, VPC endpoints, and one bill instead of another vendor, another key, another invoice, and another security review. When you want to switch between models from different providers behind one API, and note this only works if you use Converse. When a managed RAG or agent pipeline gets you to a working product faster than building one, and speed to a baseline matters more than the ceiling. Use a provider's API directly when you want the newest model the day it launches, because Bedrock is always somewhat behind and sometimes by months. When you want the provider's own richer SDK and features, which are typically ahead of the Bedrock surface. When you are prototyping and the 15-line script is genuinely all you need. When you have no compliance requirement to satisfy. And please be honest with yourself about whether you actually have one, because a lot of teams adopt Bedrock for a boundary nobody is asking them for. And here is the pattern I would actually recommend, because it dissolves most of the argument. Put an abstraction between your application and whatever serves the model. One interface, adapters behind it. Then Bedrock versus Direct becomes a configuration decision rather than an architectural commitment. And you can start with the fast option and move when a real requirement arrives, rather than migrating a codebase because your compliance posture changed. This is the same lesson as the Spring Cloud episode. Do not couple your application to a piece of infrastructure whose value is organizational and whose lifespan is unknown. Concept 8. Running it for real. 6 things. 1. Throttling is your normal state, not an exception. You will get throttling exception, and you must handle it. Exponential backoff with jitter and a queue for anything that is not user-facing. Design for it from the start rather than discovering it in your first load test. 2. Latency is measured in seconds, not milliseconds, and that changes your architecture, not just your timeouts. It means a synchronous request-response pattern is often wrong, and you should be streaming to the user or doing the work asynchronously and notifying them. 3. Costs scale with usage, which sounds obvious and is not, because there is no natural ceiling. A bug that retries a prompt in a loop is not just an error, it is an invoice, and a runaway agent can spend real money overnight before anyone looks. Put a spend alarm on it today. 4. Log the prompts and the responses, because you cannot debug what you cannot see. But redact the PAI first, because you have just built a database of everything your users typed into an AI. And that is now the most sensitive log you own. 5. Evaluate. Bedrock has model evaluation jobs, but the point is not the feature, it is the discipline. When a new model version lands, you need to know whether it is better on your task, and without an eval set you are guessing, and you will either upgrade blindly or refuse to upgrade at all, and both are bad. And 6. Version pin your model ID. Models get deprecated. Behavior changes between versions, and prompts that were tuned against one version can degrade against the next. So pin explicitly and test the upgrade rather than letting it happen to you. Concept 9. The question and the answer that lands. The question they will ask, and it is a good one, is, why use Bedrock instead of just calling the provider's API? The weak answer is because it is managed, or because it is on AWS. That says nothing. The strong answer names the 3 things and says which one is decisive. Bedrock exists for the data boundary, EM, and the network path. My prompts stay in my AWS account. Access is an IAM permission rather than a shared key somebody will commit to a repo. Every call is in CloudTrail, and traffic can go over a VPC endpoint and never touch the internet. In a regulated environment, that is the whole case, and nothing else matters. If I am not in one, the 15-line script is genuinely fine and I would use it. Then show depth. I would use the Converse API, not invoke model, because invoke model's request shape is different per model family and that couples me to one provider, which defeats the point of a multi-model platform. Then show judgment about the managed pieces, and this is where you separate yourself. Knowledge bases get me a RAG baseline in an afternoon, but retrieval quality is the product, and I will outgrow the managed pipelines chunking and hybrid search when it becomes my bottleneck, so I would not architect as though I will not. And agents do not change 0.95 to the 20th. If I know the sequence of steps, I write a workflow, not an agent. Then the security instinct. Guardrails are a content filter, not an authorization boundary. They do not stop prompt injection, and if the model has tools, my defenses have to be architectural. And the sentence that ties it together: Bedrock is not an AI product. It is a governance product that happens to serve models. Say that, and you have told them you know exactly what you're buying and exactly what you're not. Let us close the loop. Bedrock is not faster, not cheaper, and not a better model. It is the same models behind one API. What it actually sells you is three things. Your data stays inside your AWS boundary. Access is IAM instead of a key someone will commit to a repo. And the traffic can avoid the public internet entirely. If you are in a regulated industry, those three sentences are the whole business case and nothing else on the list matters. If you are not, the 15-line script is fine, and reaching for Bedrock buys you nothing but complexity. Use the Converse API, because invoke models shape differs per model family and couples you to the one provider you are trying not to be coupled to. Knowledge bases give you managed RAG in an afternoon. Take that. But retrieval quality is the product, and you will outgrow the managed chunking, so do not pretend otherwise. Guardrails are a content filter, not an authorization boundary. They do not stop prompt injection, and if the model has tools, then your real defenses are architectural. Agents do not repeal 0.95 to the 20th. If you know the steps, write a workflow, and watch the bill, because there is no ceiling. Put a spend alarm on it today. The framing to walk away with and to say out loud in an interview: Bedrock is not an AI product. It is a governance product that happens to serve models. Know which one you are buying. Subscribe.